All right, so hello everybody. I hope you're having a great day. Dr. West made a lot of headway in lecture today. Um, he's in chapter 16 now, but there's a couple things we need to finish up in 15. We're either going to start 16 later today or next Tuesday or next Monday. So just to recap what we did last time in chapter 15, we looked at these like second substitutions where we have one substituent on the ring, and we looked at the directing effects, things like that. And then we finished off doing like multiple substitutions. So we have two things on the ring and we have to figure out which one directs the next substitution. And the big things I told you to remember is we first start out with defining each group as an activator, weak deactivator, or strong deactivator. And then we figure out which one does the directing. And we know that the strongest activator, aka weakest deactivator, is going to do the directing. And I'll tell you exactly what I mean by that in a moment. So, any questions about anything we covered last time? Some people did make some comments about today's lecture. It was a lot. He went over a lot and he did it very quickly. And I know it's a lot of reaction mechanisms, a lot of new stuff. So if you guys are feeling overwhelmed, I totally understand. Hopefully, it'll make a lot more sense after we do it because I love chapter 16. It's my favorite chapter. And I like to explain it step by step in the simplest possible way. So hopefully once we get into it, you guys will feel a little bit better. Just the mechanisms. Yeah, I know. There's one really fun mechanism that I cannot wait to do with you guys. Just you'll know. You'll know when it comes up. All right. So that's being said, I can't wait to get to that. So let's finish up chapter 15. As I told y'all last time, we have like different levels to chapter 15. We did the first two easier levels, and now we're getting to the final hardest level. And we did this one example last time, but I decided to paste this table in here. And this is going to help a lot when figuring out what I mean by who's more activating, who's less deactivating, you know? So I gave you guys this, but I'm also going to send it out in like the cheat sheet thing because I have it drawn a couple different ways. This is my favorite way to look at it. And this is the most activating group. And this is the least activating group. So if you use this table to kind of figure out like what goes where, you'll be able to do multiple substitutions. That was a mouthful, and that might just sound like gibberish right now, so let's look at an example. So, this group, aka NO2, is it an activator, a weak deactivator, or a strong deactivator? Sorry, I don't know how/why the recording got paused. Basically, all we said is this group, NO2, is a strong deactivator, therefore it's a meta director. And then I asked, what about this group? And a couple people responded, and it's a trick, and I'm glad I got you now because I hope I won't ever get you again, and I hope Dr. West won't get you on the exam. So, these guys act just like esters. And remember what we said about esters. If it's attached at the carbonyl, it's a strong deactivator. If it's attached at the oxygen, or in this case the nitrogen, then it's an activator because we have this lone pair. Whereas here, we have a carbonyl. And I'm going to say, same applies to amides. So I'm just going to go ahead and for you guys to be able to reference this later, I'm actually going to put it here. And I will give you a second if anyone wants to write this down or take a screenshot or anything. Any questions on this concept? All right. So, does anyone want to change their answer? What do we think this is?
Strong deactivator that attacks meta.
Yes, precisely. Okay, so now we have two strong deactivators, and they're both meta directing, so we have to figure out which one of them is going to have the directing effects. So we're comparing NO2 to an amide. We go back to this handy dandy list. We see amides right here. We see NO2 all the way over here. So which one is the weakest deactivator between those two?
NO2 would be the weaker one.
Okay, think about it. The weaker the deactivator is, the higher up it would be on here, right? Because this one is the most deactivating group. It's the strongest deactivator. So when we're talking about weakest deactivator, we want the one closest to the top. And I'm not picking on you, to the person who answered. Everyone does that. So in this case, the yellow guy right here, our amide, would actually be the winner, I guess you can call it. So we look at what's meta to this position. We can see right here, this is meta in comparison to the yellow, and this is meta in comparison to the yellow. Okay, so there's a couple questions on this, so let's kind of take these two concepts and I'll put them next to each other so we can think about it. So, boop. All right, so whenever you have multiple groups on the ring, you're going to decide which one is the strongest activator, aka the weakest deactivator. So, up here is the most activating. So this is the best group to have on the ring. This one is the least activating. This is the worst group to have on the ring. So anytime we have two groups, we're looking for the one that's closest to here, aka furthest from here. So let's say I gave you this ring, right? We have an OH and we have a chlorine. So we know that OH is a what? I know it says it right there, but I want you guys to be involved. Yes, it's an activator and it's orthopara. And chlorine is what? It's a deactivator. It's our weird little weak deactivator, and it's orthopara directing. So between OH and chlorine, which one is the most activating? There's one person who responded to all of these, so you definitely got it solid. I hope it's starting to make sense for everyone else as well. I hope that didn't sound mean. I didn't mean for it to. But yes, so the OH is highest up on this list, and in comparison to a deactivator, it's the only activator, right? So we know that the winner is OH, and we're going to substitute orthopara to the OH. Let's do one more example. So let's say I have Cn and I have CF3, right? So as we can see from this table, both of these are strong deactivators and they're meta. So which one of these two do you think is the winner? Which one is going to do the directing?
The CN.
The CN, absolutely, because it's higher up on the list than CF3. Another way to say this, kind of like verbally, right, is that CN is the weakest deactivator. Therefore, it's more likely to direct the next substitution. And I'm actually going to write that down because it's a lot of words. So I will move this example over a little bit. And I'm going to say CN will be the director
I don't know how to explain it. It's called
because it is the weaker deactivator. So the next group will be added meta to the CN. And I will also draw in the arrows. We have meta right here. And meta is already taken. So we only have one place we can add. And then someone mentioned the additive rule. I wasn't really sure what you meant by that. I thought you meant activating. Okay. And then someone said they were kind of confused by the arrow. So I was just saying, like, from most activating going down to least activating. But if it would make more sense to you, you can just flip the arrows and you can say we're going from least active to most active. However you want to do it is fine. And then, oh, I see. Okay, so what they meant by the additive effect is if both of the groups point to the same spot, that's where it goes. That's not the best way to think about it because that usually doesn't work. And okay, someone said, wouldn't CF3 be the weaker deactivator? No. So here, maybe this is what's confusing. I'll change the wording here. So this is the strongest activator. And this over here is the weakest, or I won't say it like that. Deactivator. So maybe this is a little bit more clear when it's worded this way. I know the wording can be really difficult sometimes. So the closer you are to here, this is the most strong deactivating. This is super, 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 super withdrawing, super deactivating. This one is super, 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 super activating. And then the halogen, the reason I don't have an arrow is just because it goes strongest deactivator to weakest strong deactivator, I guess. These are the weak deactivators. And then this is the weakest activator. This is the strongest activator. Okay, some people are saying that it makes more sense now. It's connecting, so I hope that's the case. I will zoom out in case anyone wants to like take a screenshot of this or write anything down. Let me actually make it a little bit bigger so you can read it better. And don't worry, excuse me, hiccup. If it is not completely clicking right now, this is a complicated subject. This tends to be one of the hardest concepts this semester because it the wording flips people all over the place. So all of the halogens are weak, and for the purposes of this class, we're going to say they're approximately the same in strength. In reality, they're not all the same, but in this class, he's not going to say chlorine versus bromine. Which one is the stronger one, you know? So if you know they're all the same, that's fine. But that's a really great question. Okay, so let's zoom back up here. All right, so we are doing a halogenation for each of these reactions, and I'm just going to make it easy for us, and I'm going to say we're doing a bromination for all of these. So for this example, we put the yellow arrows here and here because this group was directing. So our answer will look, okay, just kidding. Our answer will look like this. These two groups don't move. But now we get a bromine here, or sorry, I know it looks kind of weird when I duplicate things for you guys for a second, but it's just going to take so much time for me to redraw things a billion times. So these two would be your possible answers. Which one of these, A or B, looks more stable to you? B. I totally agree. And the reason is steric hindrance, right? This one is clumped together. This one is far apart. This one is all clumped together. So B is less sterically hindered, so it's more favorable. All right. So you already told me a couple minutes ago that this is a strong deactivator and that it's meta-directing. What about SO3H? And while you guys tell me that, I will answer a question. It was, do we need to know which product is produced more? I will actually talk about that in 1 second, so we'll put a pin in it for now. And yes, okay, so this is a strong deactivator. It's also meta. Which one of these two is the weakest deactivator? NO2 or SO3H? Yes, and if we go back to the chart, we see SO3H, we see NO2, and as you told me, SO3H is our winner because it's higher up. So, bam. Yellow is directing. We know it's going to direct meta, so it will be here or here. Both of these products would be exactly the same. They're just mirrored, so I'm only going to draw one of them. Sorry if you can hear background noises. I hope it's not too loud. And we add our happy little bromine here. And so let me zoom out so you could see all these examples. All right, so let's go back to the question we had a pin in. Do we need to know which product is produced more? So remember when we were talking about these answers, and I told you that ortho versus para, we know that para is better because it's less sterically hindered, but ortho has two positions. So it's like, statistically speaking, it's twice as likely to land there. So Dr. West takes those two effects and he basically says this is 50-50 between the two. So it's approximately going to be the same amount. Both, there's no major or minor product, they're pretty much the same.
Yeah, it was like,
However, when we have something like this, now this isn't orthopara anymore, but there's a difference between this meta position and this meta position. And now we can see that this one is more favorable because less sterics. So the reason I wanted to bring your question back at the end is so you can get some contrast between the ortho versus para, and then the multiple substitution, so steric hindrance kind of stuff. We covered a lot of stuff. I know the pages, we were on like 2 different pages. So does anyone need me to scroll anywhere so they can screenshot or write anything down?
it was a couple hours. 2 hours, 30 minutes.
Yes. So if he were to ask you which of the following are products, you would pick both of these, but the major product would be this one. And go down a bit. I can absolutely do that. I assume this is what you mean, but okay. And then yes, I'll zoom out so you can see the whole page at once. I just know it's really tiny and sometimes people can't read it if I only do that. Okay, so I'm zooming out now.
Yeah.
Bam. You're so very welcome. My pleasure. I could absolutely just look at your syllabus, but by any chance, does anyone know when your exam is, like off the top of your head? July 13th, 2 weeks. Okay, perfect. That's what I thought. I knew it was approximately 2 weeks from now.
Yeah,
Cool. So we're pretty good to go. All right. So
we'll walk
we're going to rapid fire. Someone said they thought it was the 20th. Okay, a couple people are saying 20th. I'm not 100% sure. I know it's like 2-3 weeks, not anytime very soon, but I will double check and okay, it is the 20th. Good, good. I hope we didn't give anyone a heart attack. Okay, so as I was saying, we're going to rapid fire go through a couple of these. So this one, activator, weak deactivator, strong deactivator. Activator. So where does it direct? Ooh. Okay. So remember, whenever we see an ester, you gotta think, is it attached to the oxygen or is it attached to the carbonyl? If it's attached to the oxygen, we know it's going to be an activator. All right, so what about this bad boy? It's an activator. It's orthopara. Sweet. So which one of these two activates more strongly? So which of these is the strongest activator? Yellow, yes. So if we want to look at the table, I will pop that up for a second. So the lone pairs are always going to be stronger than the R groups. So that's a nice tip you can keep in mind. Lone pairs always stronger than R groups. So we scroll back down. We're going to substitute ortho, and para to the yellow group. But wait! Before you write that down. This will never happen. And the reason is you are not going to add a group between two existing groups. So you cannot add it in between two groups. So we are going to have two products. And again, we're still doing brominations for all of these. We have our ester and our methyl. Oh my goodness, it would be so cool if this would work. Okay, so we have the ortho product and we have the para product. Bam. Any questions? If you do have a question, you can let me know at any time. Let's rapid fire this one. Oopsie. NH2. Activator, deactivator, strong, weak. What do we think? Strong activator. Heck yeah. So we're going to say ortho para. And then chlorine. Excuse me. What do we think chlorine is?
Ortho para deactivator.
Heck yeah, dude. It is a weak deactivator, which means it is ortho para. Killing it. Okay, so which of these is going to direct?
This slow.
Ortho para activator.
Heck yeah. So we're going to do ortho. Oopsie, that's an arrow. And para is already taken. So we only really have one answer since the two ortho positions are exactly the same. We have chlorine, we have NH2, and we're going to add bromine.
Yeah.
Alrighty. This one, what do we think? Activator, deactivator. Strong, weak. Ortho, para, meta.
It's actually like
Do 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 do. Okay, we got kind of a 50-50. So this is an activator, ortho para, because this nitrogen has a lone pair. Someone said no idea. That's valid. Let's bam back here. Remember, if it's attached to the carbonyl, it's a strong deactivator.
yeah.
If it's attached to the oxygen, it's an activator. And again, the same thing applies with nitrogens. I got an oh, so I hope that was the light bulb moment. I'll come up with a stupid anecdote or something to make it click. Okay, it clicked for someone. That's all I can ask for. Okay, so oxygen, our ether. Is it an activator, deactivator, strong, weak, ortho, para, meta? Activator. And we know it's ortho, para. Sweet. You guys are killing it. Which one of these is a stronger activator?
I think the HN because of the lone pairs.
Okay, that's a good thought process. Someone said yellow, and so I will. He can
Never
trick
mind.
you with this. Yep, he can trick you with that because sometimes he can draw in the lone pairs for one of them and not the other. A couple people said yellow, and I agree. And I'm going to tell you how to logic this without looking at the table, right? They both have lone pairs, and they're both activators. This one has no other responsibilities. It has nothing. So it only donates. It donates all of its electron density into here. However, this one has this whole carbonyl. So the electrons half the time go to the carbonyl The other half of the time, they go into the ring. So this one is approximately half as effective as the yellow one. So for that reason, yellow is a stronger activator. Cool? Sort of kind of makes sense? Are we following? So we're going to go ortho. And the other ortho position's already taken. And para. So here. We're going to have 2 products. Oopsie. I don't know why I just didn't duplicate it, but this is fine. So we add a bromine here, and we can add a bromine here. Ta-da! All right, I believe this is one of the last examples. That's fine. Alrighty! Bam! We just did one like this. What do we think?
Well, like you just go through, that's like learning about different things and help people, like certain people die.
Pew pew, pew pew pew. What do we think? Activator, heck yeah, orthopara. And now it's attached to the carbonyl. So it's a what?
Now it's a weak deactivator.
Is it weak or is it strong?
Oh, it's a strong weak deactivator.
Yes. Yes. Okay. I love that you said it like that. Because one thing I want to very strongly drill in your minds, the only weak deactivators, the title weak deactivator is halogens. Those are the only ones. Okay, so between these two, which one is the director?
Orthopara activator.
Heck yeah, I totally agree. We can see the para position is already taken. So we're going to do ortho. Both of those are exactly the same. So
I do not. In I think it will.
ta-da. So I'm going to zoom out. That's the last example we're going to do today. We can use the other ones for the exam review. So I'll give you a moment to screenshot. Okay, so now that we're done with this idea, let's do a poll. 0 is I literally have no idea what you're talking about. What is a deactivator? And 5 is absolutely crushed it. I did all of these in my sleep. 3.7, 3.9. Okay, I'd love to see it. 4, if I have my notes, that's totally valid. 4.4, a 4. Okay, sweet. 3.7. Oh yeah, same if I have my notes. We're doing this for the first time, guys. I do not expect you to do it without your notes. And I just want you to look at it over and over and you'll start making connections and like remembering it. So 4.8 with some embarrassing moments. I say the dumbest thing sometimes, so you guys never have to feel embarrassed. And I totally do it on purpose. Totally. Okay. So now we're going to do my favorite part of chapter 15. We're going to do build that benzene. It is not as fun online, but we're going to make it fun. Ha! Okay. So, and someone said, I feel like after reviewing it, I'll get more into it. Good. I hope so. I trust you. Y'all are so smart. Okay. And so hardworking. Okay. So, before I get too excited, what are we adding to the ring with these reagents? So, okay, this is going to be a Lewis acid, and this is going to make the electrophile, whatever, but now we only want the fastest boom, boom, boom. We're adding a chlorine, that's it. For this one, what are we adding to the benzene ring? An R group, perfect. So, all right. For C, what are we adding to the ring? Aw, I was gonna press an obnoxious, like, wrong answer buzzer because this is where I always trick people. But you guys are right. You add an NO2. Be very careful because on the exam, I've seen him put a benzene ring with NO3, and so many people pick it just because NO3 is in the reagent. No, no, no. It's gonna be NO2. Okay, cool. You didn't even need that outburst because you already knew that, but cool. What are we adding here? Not exactly an R group, a carbonyl group. Yes, I agree. So there is an R group here, you're absolutely right, but the more important defining thing is this carbonyl right here. So we're gonna say like that. And so what about these? What are we adding with these reagents?
So it was like kind of a thing. And then throughout the year, I don't know if it was like with the
No worries. Okay, so someone asked, how do you figure out what you're adding? I'm lost. I'm sorry, whatever. No worries. No need to be sorry. It's okay. We're adding an SO3H here because someone told me that. I agree. So let's zoom back over here to way back when we did this. So we went over the mechanism, all that stuff, but for this chapter, all I want you to know is the general mechanism, and I want you to know these reagents equal this. 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 And you can, of course, right now have your notes with you, but I want you to do it so many times that it eventually is just stuck in your head. If you see SO3, you know you're putting SO3H on the ring. If you see an alkyl halide, you're putting an R group. If you see an HNO3, you're adding NO2. So, ta-da. Now we zoom all the way back down. All right. So now here comes the fun part. Okay, so we're going to do one example together, and then we're making this a game. And I will explain how the game works in just a second. So, the way you're going to play the game is the top, number 1 and number 2. You're going to figure out the order that these were added to the ring. So, we're going to go about it the same exact way. Chlorine. Activator, weak deactivator, strong deactivator. What is it? Weak deactivator. And we know that it's orthopara. What about NO2? Activator, deactivator, strong, weak. Strong deactivator, and we know it's meta. Cool. And then I want you to think, what is the relationship between these two? Are they ortho, para, or meta to each other? They are para. Right? So, if these are para to one another, which one of these had to be first? And someone already said it. They said, oh, chlorine had to be first. Yes. So this reaction had to happen first so that the chlorine could direct NO2. So A was first and C was second. And a couple people said, I don't get it. We're going to do one more example. So we already said chlorine is weak deactivator orthopara. SO3H, how would we define that?
Strong deactivator.
Yes, and where does it direct?
I think it was the
Meta.
Sweet. Okay. So what's the relationship between these two groups?
They're both deactivators.
Yes, but I mean like on the ring. What's their relationship? Yes, they are meta. Cool. So which one of these had to be on the ring first? And a couple people already said it. So SO3H had to be added first so that it could direct chlorine. So it would be E was the first reaction and A was the second. So think of it as retrosynthesis. You're figuring out how we built the benzene. Ah?
no, yeah. I like in my house
We get it? Are we cool?
like it was like since she was sick, it's a
So, well, you guys,
Chlorine was added first. Where will the SO3 be? The SO3H.
I'm so sorry. What was that?
If the chlorine was added first, what will be the SO3H?
Okay, so if the chlorine was on the ring first, right, you would either add it ortho or para. So it could have either been ClSO3H or it would be, oh my goodness, that's so ugly. Para. I know things are kind of on top of each other. And so in the first one, why was chlorine first? Chlorine had to be first because if you added the NO2 first, the second group would have to be meta because this one only directs meta. If this one is first, the next group will be added ortho or para. That's why this had to be second and this had to be first. Okay, so I am going to erase this for a moment. I'm going to do a handy dandy screenshot. And we're finally going to play the game. I know we're kind of pretty much out of time, but I really want to play the game. So if you guys are chill with it, I'm just going to keep going. Okay. Someone said I didn't get this in lecture. Trust me, I don't blame you. Okay. Okay, so the reason I'm like moving things around is because I want to share so that you can all see this. And I also want to give you all annotation privileges.
Yeah, that's why
Who can annotate? I don't want to annotate, actually. I want everyone else to annotate. I feel like once you start allow annotation, all sweet. Okay. So don't start playing the game yet. Someone's don't mind anything on my screen. Oh, you can't see my screen. Oh, thank goodness. Okay.
there was like a.
I have just random things. All right. Yes, you may annotate. Okay, so there are 9 of you, and I want you to go up to here. So I don't want you to do these. All right. You guys can see the participant list, right? Maybe?
Yes.
Yes? Okay. So, this is not. Okay, Paul, you're doing 5 and 6. Angela, you're doing 7 and 8. I'm definitely going to pronounce this wrong, and I apologize. Isangel, you're doing 9 and 10, please. Chelsea, you're doing 11, 12. Jomara, you're doing 13, 14. Maria, you're doing 15, 16. And okay, you guys got all mixed up. If I haven't given you one, you're going to do 17 and 18. I think it's going to be two people. Okay, cool. And then whoever does it first is going to get a prize. Ooh, someone already finished. Wow.
Let me just make sure.
If you don't remember which one was yours, just pick one and just do it. And okay, I'm gonna make this double interesting. If you're done and you see someone else is wrong, I want you to privately message me and tell me what you think it is. And Paul had a great idea. Write your name next to the one you do, especially if there was multiple people assigned to the same one. Pretty please, or at least just your initials. Mwahaha. I love all the different methods that people use to write because I hate annotating. It's so difficult on my laptop, and some people did it so nicely. I'm like, I'm jealous.
Like set chores, we just do whatever needs to be done and then separate it.
Boop, 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 boop. Okay, if someone wants to get extra points, 7 and 8 is still open. So you can attempt that one. But if you've already done one, just message me your answer because I want to give other people a chance if they're still thinking about it. Bum, bum, bum. I hope we're still recording. I think we're recording.
Well, the second time when he got cancer, he had to get
I hope we're recording. I can't tell.
and that basically caused him to have a new immune system. So he was had the immune system of a newborn baby, so we had to make sure everything was there's not be dust with him. Everything needs to be scrubbed down the second after someone got out. So make sure everything's top notch clean.
Bow, 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 bow.
They like make sure that every surface in the house
Okay. So I'm going to give it 1 more minute. And I'm going to do the Kahoot music for the meme. Okay, we have like 30 seconds. I feel like at this point, everyone's just sitting here like, what are you on about? Someone did change their answer though, so I'm glad I gave you the time. Okay, we're done. Okay, so everyone has a name except who did 15 and 16? And then who did 7 and 8? Pretty please either put it in the chat or...
15 and 16, I did it.
Okay, I can't see who's speaking, so could you just tell me your name, please?
Maria?
Maria? Okay, cool. And you said you did 15, 16?
Read handwriting, the C and the A.
Okay, cool.
I think somebody wrote it in like, I don't know, blue, but
Okay. Oh, I see. Okay. Cool. So Maria, and then who had done it in blue? Pretty please let me know. Trust me, you want the prize. It's so cool. It's so amazing. So cool. I'm gonna go ahead and take a screenshot of this. I want the prize. Okay. So I has screenshotted now. All right. So to keep the suspense, I am going to look at the answers. I'm going to send you guys an email with like who won and then the prize. And then on Monday in SI, I will show you like the explanation for any of these. I don't remember if I said this. I'm sorry if I'm repeating myself. I will also give you like the answer key so you know like if anything was wrong, but all these look pretty good. So I'm excited. Any questions, comments, concerns, anything like that before I leave you for the day?
I will probably come to you, but like if later on when I'm like,
Was this fun?
I could just like add it on to this comment.
Like, did you guys enjoy this, or was it just me that was getting enjoyment out of it? Someone said, what if they are both meta? So I will, depends on the prize. So someone, I will answer that question in the email because it's kind of like I'll make like a description just because I don't want to spend too much of your time. I already went 10 minutes over and I feel bad, but I will like do a step-by-step kind of thing in the email. All right. So before I let you go, we're going to kind of summarize the session. 0 is I have absolutely no idea what in the world is going on. I'm more confused than when we started. And 5 is this is the easiest garbage I've ever done in my life. How do you guys feel about chapter 15? As a whole. 4-ish, 5-ish, 4.2, 4.3. Yay! Awesome. So we're pretty much done with chapter 15. We are going to, like I said, review this Monday briefly, and then we're starting chapter 16. Yay! I'm so proud of you guys. All right, so you are free to go. I am done for now. Bye-bye. I'm going to stop the recording and then I will stick around for a minute or two if anyone has any questions. I see a couple in the chat. I just have no clue how to stop the recording. There we go. I figured it out.